Very good morning, students. Today we start one new subject now, which is nothing but which is very important for the communication students. Now that subject is nothing but communication systems. Okay. Now before we start this subject, then I want to give a few important tips of this particular subject or important features of this particular subject. And your branch itself, electronics and communication, am I right or not? Electronics and communication engineering. So students, you know the importance of the communication system in our practical day-to-day life also, am I right or not? Now you tell me, now without a communication system, now your day will not start and your day will not end. Is it right or not? Right? Now everybody will carry one communication device, right? The mobile is one of the communication device, am I not? So we start this subject not only theoretically, okay? Now we start this subject, now whatever the content in this particular subject is fully relates with the practical applications. Now in our day-to-day life, what are the different types of communication devices you may came across? Now how that devices are working, what should be the principle and what is the principle of working principle in that particular device? Now everything we will see in the classroom, okay? So this subject is fully deals with the practical orientation, practical applications. So you concentrated now how the practical systems are working, you can easily understand once our subject is going on, okay? And we start the subject from there to we'll go latest technology and all these things also we'll cover, okay? And one more thing, this is a communication system, am I right? Because our subject is a communication system, okay? Now first of all, I want to ask one simple question. Now what is the meaning of a communication? How you define a communication? Now students, now I just ask one question. Is there any communication going in this class? So is there any communication is going on this class? When I am asking a question, what is your answer? Tell me. Now you said that yes sir, some communication is going in the class. So which means that now what is the meaning of a communication? What is the basic aim of a communication? What is the main objective of a communication? Am I right or not? Now tell me, you can easily answer this question. Now a main objective of a communication system is to transfer the information from one place to another place. Is it right or not? So remember, this is the first point and which is the heart of our subject, okay? The main objective of a communication system is to transfer the information from one point to another point, right, through an electrical signal, okay? Through a signal, let us assume through a signal, okay? Now very simple question I am asking students. Now in the class, now see if you take this class, now when I am giving something, right, you all are receiving and some communication is going in between us, okay? So I am transmitting something and you are receiving something, right? So what is here? This is a simple communication. The objective of a communication is to transfer this information from this place to that place, okay? Right? Through a signal. I am asking a information here. Now I am saying a signal, okay? So the another important of this particular communication system is nothing but now information. I am asking about information, right? Information. So which type of information? Okay. So where is this information? Now some of you are saying is, sir, this information is in the signal. Okay. So this is very, very important while we are dealing with a communication systems, because you want to transfer the information. Now you want to transfer the signal. The objective of a communication system is to transfer the information from one point to another point through a signal, okay? Which means what is the signal? Okay, a signal, listen, a signal is a physical quantity which contains some information. A signal is a physical quantity which contains some information and it is varying with respect to some parameter, and it is varying with respect to some independent parameter. Therefore, now our subject is a communication system and one of your core subject is signals and system. Am I not? Now one subject is communication system, another subject is signals and system. Now these two are very important. Okay. While we are studying the communication system also, because the signal part is also very important. Okay. So don't forget about don't afraid about the signals. Okay, sir, we are not much familiar on the signals and all these things. Not an issue. Okay, so we will closely related these signals with the communication. Okay, so what is the main signal? The signal is a physical quantity which contains some information and it is varies with some independent parameter. So this information is there in the signal, right? Now, sir, what are the different kinds of signals? A number of signals are available, but I want to start with one signal which is very useful for us. So, a signal is a physical quantity which contains some information and varies with some independent parameter. Now, I just take one signal because I start this subject with a basic portion. Now this is one signal. Now see here. Now what he is saying, a signal is a physical quantity which contains some information and varies with some parameter, here some independent parameter, here it is time. So let us say this is a time domain signal x of t. Now one more point also I want to say. Now when I am speaking, now when I am transmitting a signal, what should be the characteristics you might be observed when I am delivering a signal? Now sometimes my voice level will be high, sometimes my voice level will be low, sometimes my pitch will be high, sometimes my pitch will be less. Am I not? Now this is one of the features of a signal, one of the characteristics of a signal, that is nothing but a strength of the signal. What is this? This is nothing but a strength, information, the strength of the signal. The strength of the signal is represented with amplitude. Now this is the peak amplitude A, this is the minimum amplitude minus A. So one of the characteristics of a signal is characteristics of a signal. Now one of the characteristics of a signal is amplitude, which is a strength. Now one main characteristics of signal is strength. Now the strength of the signal is represented by amplitude. If it is a voltage waveform, the units are volts. If it is a current waveform, the units are amperes. Why? Because the signal variation is an electrical variation. If it is an electrical variation, it may be a voltage variation or a current variation. Okay. So this is one of the characteristics of a signal, which is a strength, amplitude, right? Now strength of the signal. Now another characteristics of a signal, which is nothing but, now see here, this is the time taken to complete one full cycle. Now the time taken to complete one full cycle, now this is called as time period. Time taken to complete one full cycle. The number of cycles per second, the number of cycles now per second, if you take a period of time period of 1 second, now how many cycles are transmitting over a period of time? Now this is the number of cycles per second, now which is nothing but, what is the number of cycles per second? Which is nothing but the number of cycles per second, or this we call it as frequency of the signal. Frequency of the signal. Now this is very important, right? Now this is the frequency of a signal. Now that frequency of the signal, when indicates the number of cycles per second is very lesser, then it will transmit only for a smaller distance. Sir, the number of cycles per second is more, sir. Then it will traveling for a longer distance. Am I not? Now the number of cycles per second are frequencies and the units are hertz or cycles per second. Am I not? Now another parameter, another characteristic parameters of a signal, now which is nothing but now phase delay or phase difference. Phase delay or phase difference. Phase. Okay. Now this is another characteristic parameters of a signal. Now this is the phase. Sir, this is a leading phase, lagging phase, 30 degrees leading, 30 degrees lagging, right? Now there is no phase difference between the signals, in phase, out of phase. So the units are radians or degrees. Okay. Now this is omega is called as angular frequency, but in communication no angular frequency. Okay, just for theoretical calculation. Now this is the angular frequencies. You know that omega, which is nothing but units are radians per second, or omega we call it as d theta by dt, which is equal to theta is angle, radians, t is seconds, radians per second, or we can write it as omega, which is equal to, you can write 2 pi f. Okay, and this is the time taken to complete one full cycle is called as time period, and the relation between frequency and time period. Now frequency and time period is inversely proportional. So in time domain, you can easily identify that when time period is more, frequency is less. When time period is less, frequency is more. In that way, you can identify this is a high frequency signal or a low frequency signal based on time period, based on time period. When time period is very more, when time period is large, time taken to complete full cycle is very high, then the frequency is very less. When time period is very small, the time taken to complete the full cycle is very less, then the time period is less, frequency is very high. Okay, so this is the relation between frequency and time. Okay, and these are the characteristic parameters of a signal. Now why this is a signal? Because a signal is a quantity, is a physical quantity which contains some information. Understand not? A signal is a physical quantity which contains some information, and it is varies with respect to some independent parameter. Now this is one signal I am giving. Now which type of a signal it is? Now this is n number of signals are available, you know, as a communication student. Now which type of a signal it is? Now see here. Now this is the time. You take any point on the time axis. Now there exist magnitudes. For every time axis, now there is a magnitudes, amplitudes are available, which means that now this is continuous in time, right? Continuous in time. For every continuous in time, amplitudes are also continuous. Now this is nothing but continuous in amplitude. Continuous in amplitude. Continuous in time, continuous in amplitude. Now this is called as a continuous wave signal. This is called as a continuous wave signal. Now this is nothing but a continuous wave signal or a analog signal. This is the continuous wave signal or a analog signal. Now this is nothing but characteristics of a continuous wave signal, characteristics of a continuous wave signal or analog signal. This is the characteristics of a continuous wave signal or analog signal. Now tell me, what are the characteristics of a continuous wave signal or analog signal? Now first of all, it is a signal, which means that it is having some information, right? It is having a physical quantity which contains some information. Now what should be the, where is the information? Students are asking that, sir, it is a signal, he is carrying some information. Where is the information? That information is nothing but the strength. The strength is nothing but amplitude. Understand not? Now this is the amplitude, which means that now in a easy manner, in a layman language, that information is nothing but strength. That strength is nothing but amplitude. This is very, very important. So where is the information, sir? In a signal, where is the information content? Where is information part in the signal? The information part in the signal is nothing but amplitude itself. Okay. So the amplitude, the strength of the signal, the information is nothing but the amplitude itself. Okay. Now how the signal is driving is decided by the how long it is driving, a number of cycles per second or nothing but frequency, and this is a phase delay or a phase difference, units are radians or degrees. Understand or not? No. This is the characteristics of a analog signal or a characteristics of a continuous wave signal, but my heading is a communication system, but I am starting with a signal. Why? What is the relation? Now, so see here, this is one signal. Whatever the signal I am delivering in the class is one of the signal. This signal I named as a voice signal. Can I name it? This is a voice signal? Yes. Or can I name this is a speech signal? Yes. Now students, you are receiving my voice signal. Yes. You are receiving my speech signal. You are saying yes. Now what is the signal? This is a voice signal. My voice signal, my speech signal is continuously varying with respect to time. Am I not? Therefore, I am dealing with a continuous wave signal. I am dealing with a analog signal. So if you take any communication system, listen, if you take, let us take, this is a communication system. If this communication system is dealing with this type of a continuous wave signal, this communication system is dealing with this type of a analog signal, now this communication system is called as a analog communication systems. Now that devices are called as analog communication systems. Now this analog communication systems are carrying analog signals. So this is a communication system. Now I am going to start analog communication systems or analog communication topic. Now where the communication system is completely deals with a continuous wave signals or continuously deals with analog signals. Understand not? Now that is the reason why now that communication system is deals with analog signals. Now what is the meaning of analog signals? Now in the analog signal, where is the information? Now what are the characteristic parameters of analog signal, which are very, very important. Now students, because of that reason, now I just start with continuous wave signal or analog signal. Note down these important points. Okay. Okay. Now this is a very important and a starting point of our subject. Okay. So now this is the characteristics of a communication system. Characteristics of a analog signal. Now keep this analog signal in your mind, then we'll continue. Now you tell me. Now you know the characteristics of a signal and you know the features of a signal. Then tell me, what are the practical signals in your day-to-day life observation? What are the practical signals in our day-to-day life observation? Now see here. Now, sir, this is a voice signal. Yes, okay. Voice signal or a speech signal, right? Next, audio signal. Okay. Next, video signal. Okay. Now these are the signals generally now which we came across in our practical day-to-day life. Now how you can say this is a voice signal? So any signal is a characteristic parameters of amplitude or frequency or phase, analog signals. Okay, I mean to say analog signal. So based on amplitudes, the signals are different, categorized into different, and based on frequency or based on phase, the signals are classified into different types. Okay. So but the important is here is nothing but a frequency. A communication system important is nothing but a frequency. Therefore, this is the voice signal and this is the frequencies occupied by the voice signal. This is the frequencies occupied by the voice signal, 3.5 kilohertz, 300 hertz to 3.5 kilohertz. This is the frequencies occupied by the voice signal. Now, and this is the frequency. So you know that audio signal a number of times use this 20 hertz to 20 kilohertz, and this is the video signal which is nothing but 0 hertz to 4.5 megahertz. Now, what is this? What is this? These are the frequency ranges. Am I not? Listen, the frequency ranges occupied by this signal is called as what? The frequency ranges occupied by the signal is called as signal bandwidth. Okay, what is that? The frequency ranges, see here, frequency ranges occupied by the signal. The frequency ranges occupied by the signal is called as signal bandwidth. Let us take one small example. Now this is a time domain signal. Now I want to see the frequencies occupied by the signal. Now let us take, for example, this is the frequencies present in this particular signal. Okay. Now this is the signal in time domain and this is the signal in frequency domain, and these are the frequencies presented in that particular signal. See the frequencies presented in that particular signal and the frequencies occupied by the signal. What are the frequencies occupied by the signal is called as bandwidth. Now the frequencies occupied by the signal is called as bandwidth. Now this is the highest frequency minus lowest frequency. Highest frequency is 15 kilo minus lowest frequency is 5 kilo, which is equal to 10 kilohertz. This is the frequency ranges occupied by the signal. The frequency ranges occupied by the signal is called as signal bandwidth, and this is the signal bandwidth, and this is the frequencies presented in this particular signal. Okay. Now see here. Now this is called as a signal bandwidth. This is the way we can measure the signal bandwidth. Now some of you are asking that, sir, this is the signal in time domain, and how you know that the signal in frequency domain, how you can see how many frequencies are presented in this particular signal? Means you want to convert this signal into frequency domain. You want to see the signal in frequency domain. You can easily identify the frequencies. Is it right or not? So now this is the signal in time domain and that is the signal in frequency domain. So you can convert a time domain signal to frequency domain signal by using Fourier transform. Fourier transform is a tool. Here a Fourier transform is used to convert a signal in time domain to a signal in frequency domain. This is the time domain. And this is the frequency domain. So what is the meaning of that? If you want to find the signal bandwidth, now first you want to see the frequencies presented in the particular signal. Now how you can see the frequencies presented in the particular signal and convert the given time domain signal into frequency domain signal by using a concept of Fourier transform. So you can identify the range of frequencies and you can easily find the bandwidth. Clear or not, students? Clear or not? So now my question is, these are the practical signals. Voice signal, audio signal, video signal are the practical examples of the practical day-to-day life observation, and these are the signals most of the times we are dealing with this particular kind of signals. Now these are the frequency ranges occupied by those signals And what are those signal bandwidth? Okay, now what is the signal bandwidth? Now you know how to find the signal bandwidth. Now bandwidth of signal, bandwidth of the signal, bandwidth of the signal is nothing but fH minus fL. Am I right? No. Now see here, now this is the bandwidth of the voice signal, 3.5 kilo minus 0.3 kilo, which is equal to 3.2 kilohertz bandwidth of the voice signal, and this is 20 kilo minus 0.02 kilo, which is nothing but 19.98 kilohertz, and this is nothing but 4.5 mega minus 0, which is equal to 4.5 megahertz. What is your observation? Now can you observe anything here? So the bandwidth of the signal, if you observe, can I write like this? This is approximately 20 kilohertz, right? This is not approximately, exactly 4.5 megahertz, and this is also approximately 3.2. Let us assume this is 3.5 kilohertz. Now what you can observe, the bandwidth of the signal, which is nothing but the bandwidth of the signal, which is nothing but, what is this? 3.5 itself. What is this? 20 kilohertz itself. What is this? 4.5 megahertz itself. Which means that a practical signals, most of the time practical signals, the bandwidth of the signal, which is nothing but the highest frequency present in the signal. What is this? This is nothing but, all these are what? The highest frequency, present in the signal. The highest frequency present in the signal is nothing but what? The highest frequency present in the signal itself is nothing but the bandwidth of the signal. The highest frequency present in the signal itself is called as a bandwidth of the signal. Okay, the highest frequency present in the signal is nothing but bandwidth of a signal. Clear or not? Listen, this point is very important. In a next few hours we can have this practical application. Okay, the highest frequency present, whatever may be the highest frequency in the signal, itself will be the bandwidth of the signal. Is it right or not? Now this is the bandwidth of the signal. This is the bandwidth of the signal. Now what are the examples in a voice signals? What are the practical examples? Examples of voice signal, examples of this kind of signals. So what are the examples? Now this is a voice signals, which is nothing but, now this voice signals is nothing but a telephony signals or not? Telephony signals. Now this is the audio signal, which is nothing but FM radio or AM radio radio signal. Okay, now this is a video signal, which is nothing but a TV signal consisting of audio as well as video. TV signal. Now this is the radio signal is example. Now this is the telephony signal is example of this voice, audio and video. Okay, and one more thing, if you observe, now this is 300 to 3.5, 300 to 3.5. Now this is 20 Hz to 20 kilohertz. Is it right or not? Now see here, this is 20 Hz to 20 kilohertz, Now this is 300 to 3.5 kilohertz, which means this is the voice. Now what is this? This is the audio. Am I not? This is voice. This is audio. Now what you can understand? This is the audio range and this is the voice range. Therefore, this voice is subset of audio signal. And any sound we are able to hear, okay, any sound, whatever may be a sound we are able to hear comes under the audio signal range. Okay, any sound we are able to hear comes under the audio signal range. Okay, therefore we just normally used as a audio signal, or can my voice signal is audible, like that we are generally asking. Okay, now is it audible to you? Which means that now this is any sound we are able to hear is called as an audio signal. So if you design an audio communication system, students, if you design an audio communication system, it will automatically transmit a voice signal. But if you are strictly designed only for a voice signal and it is not able to transmit the total audio signal information. Therefore, if you design an audio system, and automatically it will transmit the voice range also, right? Because our voice is a subset of the audio signal. Clear or not? So these are the practical day-to-day life signals which we are used, which we are dealing with now, which we are came across in our practical day-to-day life, and those are the frequency ranges occupied by the signals, and this is the bandwidth of the signals, and these are the examples of those signals in our practical day-to-day life. And the highest frequency of the signal itself is the bandwidth. We call it as a bandwidth of a signal will be the highest frequency present in the signal. Okay, is nothing but bandwidth of the signal, practical signals. Okay, so these are the practical signals. And how to find the frequency ranges? Now by using a Fourier transform, we can see the bandwidth occupied by the signal and we can able to find the bandwidth. Okay, note on this first. Okay. These are the practical signals, and in our subject also, now first we want to see this signals, how it is transmitted through a communication system. Okay. Now one more thing also, now one more practical signal. Okay. So now any two friends are discussed, definitely now this word comes into the picture. Now this is nothing but data signal, right? You don't understand what is the meaning of data? Now the example of that data signal, if I am saying, you can easily understand. Now the example of the data signal is nothing but internet, 100 Mbps, right? 10 Mbps, 1 Gbps. Okay. Now this is the examples of the data signal is nothing but internet. So what is the meaning of that? What is the meaning of 10 Mbps, 100 Mbps? You are saying speed. What is the meaning of speed in here? Now this is 100 megabits per second, 10 megabits per second, 1000 megabits per second, right? 1 gigabits per second. Now this is nothing but data signal. But what are the frequency ranges occupied by the data signal? What is the meaning of data? You are saying, sir, packet, sir. What is the meaning of packet? Sir, digital, sir. What is the meaning of digital? Now which is nothing but now bits. Now here the information is nothing but ones and zeros. Now which is nothing but a train of rectangular pulses. Am I not? Now this is the data signal. now which is nothing but ones and zeros, rectangular pulses. Rectangular pulses. Now this rectangular pulse is having some pulse width. This is the pulse width. Now this T is nothing but pulse width. Okay. So then what is the bandwidth? What is the speed? This is the bandwidth. This is the speed. This is nothing but a bandwidth. Now in analog we call it as a bandwidth. In digital we call it as a bits per second. Cycles per second is frequency. Now bits per second is nothing but bit rate. Okay, bit rate. Now this is a bit rate. Now in a easy language we may call it as a bandwidth. Now this is the rectangular pulses. Therefore the bandwidth of a data signal, the bandwidth of a data signal, bandwidth, or we call it as a bit rate, bandwidth or bit rate, bandwidth or bit rate of a data signal depends upon pulse width. Okay, depends upon pulse width. Sir, what is the relation, sir? If less pulse width, more bit rate, or more pulse width, less bit rate, what is the relation? You can understand the relation very soon. Okay. Now this is listen. I just give an overview of the signals what we are practically dealing with: voice signal, audio signal, video signal, data signal, telephony signal, right? Radio signal, FM radio, AM radio signal, TV signal, and internet, right? Now this is a voice, and which is a subset of the audio signal, or any sound we are able to hear is comes under audio signals. These are the signals in our practical day-to-day life. And first I want to know that how these signals are transmitted, how these signals are transferred from one point to another point. If you want to transfer these signals from one point to another point, we need a communication system. We need a communication device. Okay, what type of communication system which we are using? Because you are dealing with analog signals, then that communication system is called as analog communication systems. And one more point is also identified. Now this is the data, this is the bits, ones and zeros, these are bits. Now binary 1 means this is plus 5 volts. Let us take binary 0, this is minus 5 volts or 0 volts. Now what is this? This is the electrical pulses. These are the electrical pulses. Okay, this is plus 5 volts, minus 5 volts. These are the pulses, electrical pulses. But what about this? Now practically this voice, this audio signal, this video signal, these signals are non-electrical signals. This voice, audio, video. Now these signals are this voice, audio, video. Now these signals are non-electrical signals. Non-electrical variation. Okay, these are audio, video signals. These are the non-electrical signals. Now we want to convert it into an electrical variations. Okay, now these are the basic informations of the signals. Okay, no doubt. And while we are dealing with the basic portion, and I am also saying that how to find the frequencies present in a signal. How to find frequencies present in a signal. Now there I am also explaining a concept of Fourier transform. What is the use of Fourier transform here? A Fourier transform is used to convert a signal in time domain to a signal in frequency domain. If you want to see the frequencies present in a signal, now first you want to see that signal in frequency domain, means you convert a time domain signal into frequency domain signal by using the concept of Fourier transform. We just go through a look of Fourier transform. Okay. Now, what is a Fourier transform? A Fourier transform is used to convert a time domain signal into a frequency domain signal. X of t is converting into x of f. Time domain signal to frequency domain signal. Now, what is x of f? Now, this is x of f, which is integral minus infinity to infinity x of t e power minus j 2 pi ft into dt. X of f, right? Now a time domain signal is converted into frequency domain signal by using Fourier transform. A time domain signal is converted to frequency domain signal, right? So then you can identify the frequencies presented in that particular signal. So we'll take one small example and we'll identify. This is a Fourier transform. No sir, now I want a time domain signal from frequency domain signal. I want a time domain signal from frequency domain signal. Now that is the inverse Fourier transform. Now this is the Fourier transform and this is the inverse Fourier transform, integral minus infinity to infinity. Now this is x of f e power plus j 2 pi ft. Now this is x of f, integrate with respect to f. Okay. Now this is x of omega, this is 1 by 2 pi x of f, therefore there is no 1. Okay. Now this is inverse. Now this is Fourier transform. This is Fourier transform and this is inverse Fourier transform. This is Fourier transform. This is inverse Fourier transform. Okay. So, but we concentrate here a time domain signal to frequency domain signal. Now we'll take one small example and how a signal is converting from time domain to frequency domain. Okay. Now, note down this. Now, first of all, I want to find that. Now, this is one signal. This is a signal in time domain, rectangular pulse. Now, I just take one signal, a rectangular pulse, whose pulse width is, rectangular pulse means pulse width capital T, pulse height or amplitude is capital A, pulse width, pulse height or amplitude. Now this is a rectangular pulse and its feature. Now I want to find frequencies presented in the rectangular pulse, or we call it as a bandwidth of this rectangular pulse, means we want to convert a time domain signal to frequency domain signal by applying Fourier transform. Already Fourier transform is available here, so you applied here. So which is nothing but integration minus t by 2 to plus t by 2. X of t means a e power minus j 2 pi ft dt. Therefore, which is nothing but a by minus j 2 pi f e power minus j 2 pi ft or limits minus t by 2 to plus t by 2. E power minus j 2 pi ft, right? Now this is our limits by minus j. Now see here, which is nothing but a by minus j 2 pi f. Now which is nothing but minus minus cancel, sorry, 2 cancel, e power minus j pi ft and lower limit is minus minus cancel, e power plus j, 2 to cancel, pi f t. Now this is x of f, this is x of f, and this is x of f. Now this is x of f, which is equal to a by minus j 2 pi f e power ix minus e power ix. Okay, so if I take this minus as a common, e power plus j pi f t minus e power minus j pi f t. Now this is minus, this minus cancel. Now what is x of f? Now this is x of f, which is equal to a by j 2 pi f, which is nothing but e power plus j pi f t minus e power minus j pi f t. Now e power ix minus e power minus ix. Therefore, x of f, which is equal to a by j 2 pi f e power ix minus e power minus ix to j. Now this is sine pi f t. Now this 2j cancel. Now what is x of f? Now this is x of f, which is equal to a into sine pi f t by pi f, sine pi f t by pi f. Now if this is multiplied with t and divided with t, therefore sine pi f t by pi f t. Now this is nothing but x of f. What is x of f? Now this is a t sine pi f t by pi f t, which is nothing but sinc x, which is sine pi f t by sine pi x by pi x, sine pi x by pi x, which is nothing but sinc function sinc of x. So sine pi x by pi x is nothing but sinc x is nothing but f t here. Now this is x of f, which is nothing but a t sinc f t. Now this is the signal in frequency domain. Now this is nothing but signal in frequency domain. Now that signal is nothing but sinc signal, sinc function. But I am not interested on all these things. What I am interested on finding the bandwidth of this particular rectangular pulse. Now this is the rectangular pulse, a signal which is in time domain, amplitude is a, pulse width is t. I want to see this signal in frequency domain and I want to find the bandwidth. Okay, note down this and we will draw the signal in frequency domain. Okay. Now like this, if you take any signal in time domain, apply Fourier transform and see the signal in frequency domain and see the range of frequencies present in the signal, and we can able to find the band. Now see here. Now this is the signal in time domain by applying Fourier transform. Now this is a signal in frequency domain. Now ft, when ft equal to 0, f equal to 0, then x of f is 80. Now x of f is 80. Now this is 80. Now when ft equal to 1, when ft equal to plus or minus 1, f equal to plus or minus 1 by t. Now x of f, which is equal to 0, which means that now this is 1 by t, this is 0 crossing point, minus 1 by t, 2 by t, minus 2 by t, 3 by t, minus 3 by t, 4 by t, minus 4 by t, and so on, and so on. So ft equal to plus or minus 2, f equal to plus or minus 2 by t, x of f, which is equal to 0, and so on. Am I right? These are the 0 crossing points. These are the 0 crossing points. Why? Because when limit ft tends to 0, sin pi ft by pi ft, now pi multiplied sin theta tends to 0, sin theta by theta, this is nothing but 1. This answer is 1. Sin pi ft by pi ft, this is 1. Therefore when pi ft tends to 0, ft tends to 0, f is tends to 0, right? Now similarly, when ft equal to 1, sin pi by pi, sin n pi equal to 0, because now here is n is nothing but ft, which is equal to 1, 2, 3, and so on. For all these values, now which is nothing but 0. Okay. So this is the rectangular pulse in time domain. This is the sinc function in frequency domain. Note on this.